Hello, folks. How are you doing? This is Saddam and we are meeting after a long time. But here I have something new for you. So I'm making a course structure type of video in which I am first starting with mathematical physics course. In this course, you are going to find, something more interesting kind of, videos. My first would be in the multivariable calculus. So I'm covering mathematical physics, and in the mathematical physics, I am going to focus on multivariable calculus. It has several reasons. First of all, it is kind of a very advanced one. And second one, it can make, if you understand these concepts, it can make your life very simplified because we have a lot of tricks in our bucket, and that's why it is very interesting. In another approach, you can see that if you want to get into the research and if you want to explore many more interesting ideas, then again it's going to help you a lot. So that's why we are going to jump in that section and we are going to start whatever we have things. But first of all, I am give you the course structure, that how we are going to progress in this thing. Initially, our first part of the video would be on multivariable calculus, let us say 1, and in second part, we are going to cover multivariable calculus part 2. So the thing is that the whole thing, because in multivariable calculus, there are a lot of topics. I have classified them into, I have break down into 7 topics. So first of all, we are going to cover something basics, which is interested to 11th class 12th class standard students, as well as also we're doing BSc, or maybe if you want to crack some exams like IIT exams, or maybe some JEST exams, or any international exam. For an example, let us say you are qualifying for SAT or maybe GRE and all these things. So this is so that's why that is the broad spectrum of this one. So multivariable calculus, and it is very much interested to MSc students who is actually entering the first year of MSc, and he or she has to learn a lot of new tricks in order to understand quantum physics as well as classical mechanics part. And when you try to understand Lagrangians and Hamiltonian concepts, if you are willing to understand a lot about general relativity and quantum field theory, then again these are going to help you. So that's why I have made a very interesting video. But before that, whatever I'm going to cover, I am just listing down. So first of all, in the part 1, I'm going to talk about vector and coordinate geometry in 3Ds. For 11th standard students, or maybe the first year of BSc, you understand you have invested a lot of time, studying in 1D, in one dimension, but now we are going to jump in 2D as well as 3D. So here you understand that in 1D, just line is line, but it becomes a plane or a surface in 2D and in 3D. So we are going to understand it from using the vectors. So you have already talked about vector, you have done the cross product and dot product. You have talked about different things, but here we are going to do it in a mathematical approach, and also we will be studying more about more about the physics part, and what is the physical implications. All right, so we are going to study vectors in 3D, cross and dot product. And another thing you haven't heard of, in cylindrical and spherical coordinate system. These coordinate systems are actually most important. You may have heard of with the Euclidean coordinate system, where you have x, y, z, and it has the cubic kind of symmetry. But here we are going to talk about the cylindrical. Let us say our coordinate system is cylindrical, maybe a spherical one, maybe a ball type. Then what will happen? Then we are going to talk about a little bit of linear algebra, in which we are going to talk about the matrices, determinants, and the symmetric of matrix, how to take inverse of any matrices, determinants, and as well as a lot of adjoints in this one. Now linear algebra is very interesting, and as well as most important if you want to understand quantum mechanics, as well as any feature. For an example, a lot of if you want to solve any couple differential equations, and you want to do programming, maybe you are interested in machine learning, so this linear algebra is going to help a lot. So for this, I am basically but taking 8 lectures. Now 8 lectures is based on 30 minutes of time. Now in second, we have going to cover vector functions and curves. Now for an example, what is vector functions? You have already understand vectors in 3D. Now you have some kind of function which is depending on x, y, and z. So the function has become 3D. Now when you are actually going from one dimension to two dimension, everything will becomes a curve. So when we have a curve, then we have to parameterize it. We have to study how this parameter is, how this curve will look like. For an example, the most simple one is the circle. So how are we going to understand anything which is related to the circle? So vector function of one variable, first of all, we are going to, get some idea of how we are going to treat of a vector functions or any function which is depending on just only one variable, and then we are going to extend it to the more variables. Then we are going to understand how to take the derivatives, and then we are going to understand about the parameterizing of any curves. That okay, let us say we have x and y, but they can depend on, let us say, some t can be time or something other space. We can analyze it. So I think it is, very broad topic. That's why I have labeled it as a 12 lectures for the 30 minutes. Obviously, I'm understanding that it is going to take a lot of time, but I will try to, give you the most important part is the physics. I will show you some part of calculations, but mainly I'm going to discuss that what is the important part, how you're going to understand those concepts and, move on and all these things. So I'm not going to, bore you with a lot of calculation step, but if you want the intermediate steps, I will provide you some more videos. Now, thirdly, I'm going to talk about partial differentials, how to take partial differentials. So, for an example, you have already studied the total differential equations df over dx, but when your function is depending on more than one variables, then this total differential equations will be divided into a partial differential equation. So, we have to understand that how we can take the partial derivatives. Therefore, we have to start with limits and continuity, as we have already understand in the total differential of the function which is depending on one variable, that the function has to be continuous, the limit must be exists. So this is how so then how those concepts are going to help in partial derivatives, right? And then we are going to understand about the wave equations and Laplace equation, which is extremely important if you are going to understand the wave phenomena, let us say in thermodynamics, some wave equations and all these things. Then we are going to talk about chain rules, some linear approximations, gradients, and directional derivatives. Gradients are too much important, let us say, because some quantity like temperature, local quantity depends on the where you are, means it depends on the space, so it becomes a local quantity. So when you have to find out there how some temperature will change depending on the spatial part, then you have to take its gradient. So gradient is again a very important part. And then we are going to understand about implicit and Taylor series expansion. What is implicit function, as well as how we can do the Taylor series expansion of function depending on more than one variables. Now we are going to talk about the application of partial derivatives, where we can find the partial derivative application. For an example, we are going to study Lagrange multipliers, Newton's method to optimize some functions, entropy and statistical mechanics, some concepts of entropy and statistical mechanics, and then we are going to also study about extreme values where the function can become maximum or minima. Then we are going to, in the part 2, we are going to read multiple integration. Multiple integration is again most important, since you have done the partial derivatives. Therefore, the antiderivative, so antiderivative becomes an integration. So how are we going to take, how are we going to, use the concept of double integrals, triple integrals in a different coordinate system, or maybe the how we are going to treat how the integration basically takes place if a function is depending on, let us say, x, y, and z, and how does it look like. Then we are going to study the vector fields, the conservative of fields, some vector fields. For an example, electric field, gravitational field, they are the conserved field. So what happens mathematically if when you're talking about such fields? Now we are going to study line integrals of vector fields, and then surface integrals. So there are too much important part. Let us say you have a ball. Okay, in the ball you can define your vector fields, but in the surface of the vector fields, right? So how you gonna take the surface integrals of those vector fields? Let us say how you're going to talk about the line integral. So let us say you are doing the electric field. Electric field is depending on x, y, and z. How are you going to take this line integral? How are you going to take the line integral of this field? Then we are going to jump to the very important thing is vector calculus. If you want to understand more electrodynamics part, all right, where we are having electricity and magnetism, then these concepts are extremely crucial. Multiple integrations, vector fields, and vector calculus. So in vector calculus, you are going to understand a lot of theorems. For an example, we are going to understand Green's theorems, Stokes theorems, application of vector calculus we are going to deal with. And again, we are going to understand how the gradients, what is the meaning of gradients, how the divergence actually play out. Suppose the divergence of magnetic field is equal to 0. What does it mean? What is the mean of gradient of electric field? So in order to understand these concepts, these crucial concepts, then we have to do a lot of things. And for this part, I have labeled it which one is going to how many lectures. So please mind it that our lecture is going to be fully in English. And secondly, that I am going to, jump from physics as well as the mathematical part. So we are doing basically mathematics, but from a physical perspective. I'm not going to bore you with the intermediate steps in mathematics. I will give you the glance that, okay, I will just write that, okay, this is the meaning, how we are arriving this one. And I will left the intermediate parts for as a homework. And then I'm going to arrive at the result. And then we are going to extensively talk about result and what is the meaning. So these going to very interesting. Why? Because it's not be the boring, and second all, you what you will get is that how this mathematics is actually giving you the way to understand nature, because what we are interested in understanding the nature, and how mathematics will help you to understand the nature is our actual going to be a very more important task. And again, if you finish this part, then you are very much equipped for any exams as well as the research. Okay, in research you will find these things very important, and they demand it that you must know this multivariable calculus. So my course on multivariable calculus will be free, available at YouTube at Saddam Leonardo Cap. You can just quote Saddam Leonardo Cap multivariable calculus, you will find it. I have also a channel in which I explicitly show how to do research and all these things, how and I also make the research related videos. It will be, very important for you. You can check it out if you are very interested in doing some research and so on. Now for the reference part, I'm going to use some references. For an example, there are some books, a complete course by Robert A. Adam or Christopher Essex. It will be primary book based on which I am designing my lectures. Second is an intuitive and physical approach by Maurice Klein. Thomas Thomas Calculus by Joel Hess et al. And a collection of problems in differential calculus by Vesselin, Jungik, and et al. So I'm sorry if I'm not pronouncing something bad, and if I'm going fast, you can let me know in the comment box. My comment box will be open to you. I will take you all your necessary questions, and I have also a website you can visit. Just click on the description box. I'm giving my website's link. You can contact me, or you can just text in the box, and you will find everything which is related to these courses. I'm going to, upload maybe 3 videos per week, and you will find all these things. Please, so I would like to, ask for a favor that you please share with these videos to your friends or anyone who is, interested learning these concepts and so on. So this is the Leonardo Cap. For today, we are going to end this video now, and then we are going to, start with vectors and coordinate geometry in 3D. So see you later. Thank you very much. Bye bye.